amount of current will not be fixed, so we need to find the RMS values. So we will use the formula to find the RMS values, but they have given that they have connected to 220 volt, right? So the formula used for this one, so before that we need to write what they have provided you. R resistance is 100 ohm, voltage applied is equal to 220 volt, and the frequency of the frequency is 50 hertz, right? 50 hertz. Now the current IRMS, if you want to find the IRMS, so this will be equal to voltage applied, voltage by the resistance. So this will be 220 divided by resistance is 100. So this is basically 2.2 ampere, right? So this is part A. Part B, they are saying that what is the net power consumed, right? So the net power consumed, that is equal to power is equal to VI. So that is IRMS. So this will be 220 into 2.2. This is equal to 484 watt. So I hope you have understood this one. So let's go for next question. Next question is read first of all. Question number 7.2. The peak voltage of an AC supply is 300 volt. What is the RMS voltage? Peak voltage. What is the peak voltage? Maximum voltage. It is not RMS voltage, right? So it's a peak voltage, right? So peak voltage means we can denote it by V naught, and this is equal to 300 volt. What is the RMS voltage? So they are asking basically VRMS. VRMS is equal to what? So we know that VRMS is equal to peak voltage divided by root 2. So this will be how much? This will be 300 divided by root 2, and basically we will get finally VRMS as equal to 212.1 volt. So this is what we have done. This is part A. Now we will do part B solution. Part B, they are saying that the RMS value of the current in an AC circuit is 10. That is, they have given IRMS. So IRMS they have provided you as 10 ampere. What is the peak current? That is, I naught is equal to how much? So we know that I naught is equal to root 2 times of I. So this will be 1.414 into 10. So this will be 14.14 ampere, right? So this is the peak current. So I hope you have understood this one. Now let's go for next question, that is question number 7.3. In question number 7.3, a 44 millihenry inductor is connected to a 220 volt 50 hertz AC supply. Determine the RMS value of the current in the circuit. So first of all, we need to understand the diagram, understand the circuits. So there is a circuit, and this is inductive circuit, right? Because they have given an inductor, so let us draw it. So this is an inductive circuit, and it has been connected with the AC supply, right? So they have also provided you the value of inductance, that is equal to L is equal to 44 millihenry. So 44 millihenry means 44 into 10 to the power minus 3 henry we can write, right? And it has been connected to a 220 volt. So voltage, amount of voltage they have given you 220 volt. Got it? And the frequency of this voltage, that is V, is equal to 50 hertz. What they are asking, determine RMS, IRMS. They are asking IRMS. So what to do in this one? So first of all, we need to find a inductive resistance, right? That is XL. XL is equal to what? We know that XL is equal to omega into L, but they have not provided you omega, they have provided you simply frequency. So to convert this one, so we have to use this omega formula. Omega is equal to 2 pi into frequency into L. So finally, if you put this value, so you will get XL. So XL is equal to 2 pi frequency into L. This is our XL, right? Now IRMS current, root mean square current is equal to applied voltage, that is VRMS by XL. So we can easily find out. So VRMS is how much? 220 volt divided by XL means 2 into pi. Pi means pi. Let us write pi. Frequency they have provided you 50 into L, that is 44 into 10 to the power minus 3. Now rearrange this equation. So this will be 220 into 10 to the power 3 divided by 2 into 3.14 into 50 into 40. Oh, so when you calculate this one, so what you will get? You will get approximate values of this one is equal to 15.92 ampere, right? So this is our IRMS. So I hope you have understood this one. So let's go for next question. Sorry. This is question number 7.4, and in question they are asking a 60 microfarad capacitor is connected to 110 volt having a 60 hertz AC supply. Determine the RMS values of the current, that is they are asking again IRMS. But the thing that in this circuit they have connected a capacitor with the AC supply. So AC supply will be like this, and capacitance of the capacitor is 60 microfarad. So we can write 60 into 10 power minus 6 farad, and voltage they have given you 100, sorry, it is 110. The voltage they have provided you 110, voltage they have provided you 110, and frequency they have provided you 60 hertz, right? Now let us do this problem. Now how to find IRMS? So to find IRMS we have to put a voltage, that is V, by a resistance, but which type of a resistance? Here a capacitive resistance, so that is XC. What is XC? Voltage. What is the value of XC? XC is equal to 1 by omega C, right? XC is equal to 1 by omega C. So 1 divided by omega C. So this will be how much? This will be, let us check it. So put the values now. IRMS will be equal to V into omega into C, and the value of omega, we know that omega is equal to 2 pi frequency. So finally IRMS. So IRMS is equal to V, that is voltage, into omega means 2 pi into frequency into capacitance. So voltage is 110 into 2 into pi is 3.14 into frequency they have provided you 60 into capacitance is equal to 60 into 10 to the power minus 6. When you multiply it, so just check it how much you are getting. Just pause the video and try to do the calculation. So I hope you will get approximate the value will be 2.49 ampere. So this is the IRMS. So I hope you have understood this. Let's go for next question. Yeah, now let's go for next question, that is question number 7.5. In exercise 7.3 as well as 7.4, what is the net power absorbed by each of the circuit over complete cycle? So they are asking net power absorbed. So first of all, need to know question number 7.3. So 7.3, it's a purely inductive circuit. So what will be the power consumption, right? So the value we will use from here only IRMS we have a 15.92. So let's go and try to solve this one. See, in question number 7.3, they have told 7.3, they have told that it is purely inductive circuit. Which circuit? Inductive circuit. It means that the circuit contain this one, right? Circuit contain this inductor. Got it? Now where I have got IRMS is equal to 15.92 volt on that question. If you go and just check it, and the voltage VRMS will be how much? They have provided you 220 volt, right? Now net power absorption will be how much? So net power absorption in one cycle, sun in one cycle, so that is equal to P is equal to VI cos phi. Now what is phi? Phi is the phase difference between phase difference between current and voltage. Current and voltage. Now if you observe this one, this diagram, if you observe, so the angle between this one is how much? 90 degree. So that is phase difference is 90 degree. So the phase, that is phi, is equal to 90 degree. Now put the values for the solution. So here we will go for a solution. So power is equal to V into I into cos 90 degree. So basically average power will be 0 for a pure inductive circuit. So I hope you have understood this one, right? Now let's go for a question number 7.4. In 7.4, it is pure capacitive. If you observe this question, it is pure capacitive and IRMS is equal to 2.49 ampere. Now let's go for solving this one. So since it is your pure capacitive, and what they have provided, what we have got actually IRMS. So it is pure capacitive circuit. So if it is your pure capacitive circuit, so this will be capacitor. This is a power source, and in this what we have got IRMS, and the I value of IRMS is equal to 2.49 ampere. Yeah, 2.49 ampere, and VRMS is equal to 110 volt, right? So they have provided you. Now net power absorbed will be how much? So again you need to understand that what they have given you. So this is current one, this one is current, and this is voltage, and this, the angle between these two, current and voltage, that is phase difference, is 90 degree. So they have provided you phase difference for this one will be 90 degree. So we need to find out the power. So power is equal to VI cos 90 degree. So V means 110 into current means 2.49 into cos 90 degree. So this will basically become a 0. So average power will be 0. So I hope you have got this one. So if you have any type of doubt, you can ask me. So let's go for next question, that is 7.6. Now in 7.6, a charge of 30 microfarad capacitor is connected to a 27 millihenry inductor. What is the angular frequency of a free oscillation of the circuit? So you need to understand, very important, that there is circuit in which what they have given you. In the circuit they have given there is a capacitor and there is a inductor. So basically what will happen? It is It is basically LC circuit. Got it? And in LC circuit, what they have given you? Capacitance 30 microfarad means 30 into 10 power minus 6 farad. And inductance they have given you is 27 milliampere, that is 27 into 10 power minus 3 ampere. Henry, sorry. Now what they are asking? What is the angular frequency of the oscillation? So whenever they are asking angular frequency, that is omega, they are asking omega, right? Angular frequency. Simply frequency means this one, and angular frequency means omega, right? Now omega that is R is equal to 1 by root under LC for LC circuit, right? So this will be how much? 1 by root under 27 into 10 to the power minus 3 into 30 into 10 to the power minus 6. So just calculate it. So I will get 9 into 10 to the power minus 4. So the answer for this one will be omega R will be how much? This will be 1.11 into 10 to the power minus 3 radian per second. So I hope you have understood this one. So let's go for next question, that is 7.7. Now 7.7, right? Read question carefully first of all. A series LCR circuit with R is equal to 20 volt ohm, L that is inductance is equal to 1.5 Henry and capacitance is equal to 35 microfarad is connected to a variable frequency of 200 volt supply. When the frequency of the supply is equal to the natural frequency of the circuit, what is the average power transferred to the circuit in one complete cycle? So first of all, you need to understand the circuit, right? So in this circuit, they have given you resistance or LCR. So first of all, I will draw LCR is better pronunciation. So I will draw L, after that capacitance, after that resistance. So this is L, this is C, and this is R, and this has been connected with the AC supply. This has been connected to a AC supply. So let's connect it with the AC supply. This is a AC supply, right? And this is the circuit, right? So let's put the data whatever they have written. So they have given R is equal to 120 ohm, L is equal to 1.5 Henry, and the capacitance C is equal to 35 microfarad. Is connected to a variable frequency voltage, that is voltage they have given you, your VRMS they have given you 200 volt, right? When the frequency of the supply is equal to the natural frequency, the circuit, what is the average power transfer, right? What do you mean by this? First of all, we need to know that what is Z. It is your impedance, right? For a LCR circuit, Z is an impedance. So Z is equal to impedance, and this is equal to R square plus XL minus XC whole square, right? Now you are thinking that what I am doing, why I am doing. So we need to find the average power. So average power is equal to V into I, right? V into I. Got it? Vi cos phi. Let's write like this. So this is the formula, average power for the complete circuit. Now what they are asking, when the frequency of the supply is equal to the natural frequency, whenever we know that when frequency of supply is equal to natural frequency, whenever frequency of supply is equal to natural frequency, then what we can say that XL is equal to XC. I hope you have remembered this one, right? This is a part of the derivation. So XL is equal to XC. So from there we can say that Z is equal to root under R square plus 0. So this will be basically impedance is equal to resistance. So it means that it is your purely resistive circuit. It is purely resistive circuit. So in this, the phase difference will be 0 degree, right? So the average power, if you want to find now average power, so power is equal to how much? V into I. So how to find I? Since it is your purely resistive circuit, so we can write like this. V into I means current means equal to V by R. So this will be Z. So finally V square by Z. So V square means 200 square 200 square, sorry, I have not written in proper way. So let's rub it. I hope you have understood. If you have a doubt you can ask. Okay, so this is V. So V square, that is equal to 200 whole square divided by Z. Z is equal to how much? Z is equal to how much? Since Z is equal to R, so R they have provided you 20. So Z is equal to 20. So it will be how much? So when you calculate it, so final power will be equal to, it is your 200 into 200, right, divided by 20. So this is got cancelled. So this is 10. So basically you will get 2000 watt, 2000 watt or 2 kilowatt, whatever suits for you, you can write it. So I hope you have understood this one. So I hope you have understood this solution. Let's go for next question, that is 7.8, right? In 7.8, what they have given in a figure 7.17 shows LCR circuit connected to a variable frequency 230 volt. So this is LCR means L, capacitance and R, right? And it has been connected to the source voltage of 230 volt, right? Source L is given as 5 Henry, C is given as 80 microfarad and resistance R is given as 40, right? So I hope you have understood this diagram. So let's try to solve what type of question they are asking. First question, what they have asked. First question they are asking, determine the source frequency which drives the circuit in a resonance. Got it? Whenever there is a resonance, so for determine the source frequency, right? So for resonance, what you know that? So let's go for this one. A part, for resonance condition, XL is equal to XC, and from this we can derive that omega for the resonance will be equal to 1 by root under LC. Now what they have given you? They have provided you L is equal to how much? 5 Henry. So let's write here L is equal to 5 Henry, and next they have provided you C is equal to 80. C is equal to 80 into 10 power minus 6 farad. Now put the values so that we can get it. Put the values. So omega R, here omega R will be how much? Omega R is equal to 1 by root under LC, means root under L means 5 into 80 into 10 to the power minus 6. So when you write this one, so this will be approximately 5 radian per second. So this is the answer for this part. Now next part, let us solve next part, that is B part. In B part, what they have told you, obtain the impedance of the circuit and the amplitude of the current at that resonating frequency. Now what to do now? Impedance means Z, and Z we know that root under R square plus XL minus XC whole square. Now since this is a resonating condition, so if this is your resonating condition, so it means XL is equal to XC. So if XL is equal to XC, so Z will be become like R, right? So if XL is equal to XC, so Z will become like R, and this is equal to 40. Okay, why 40? Just they have provided you, check it, resistance they have provided you as 40. Since R they have provided you 40, right? So we have got impedance is equal to Z is equal to, that is impedance is equal to 40. So this is first part of the answer. They are also asking you the current. So current, what will be the value of current? That is current is equal to I naught, and this will be equal to V naught divided by Z, right? Now they have given you a voltage that is equal to, in this question if you observe, so the voltage they have given you how much? 230 volt. Voltage they have given you 230 volt, right? So let's write this one. uh 230 volt, okay, it's fine, voltage is equal to 230. Got it? But they are asking, we need to use this one, right? V naught. So V naught basically means peak voltage. Peak voltage will be always equal to root 2 V into RMS. And this is basically RMS they have given you. So we need to put like this and divided by Z. So just put the value now. So this value will be how much? Just put it. So it will be root 2 into VRMS means 230 divided by Z means 40. While you calculate it, just try to calculate it. So you will get 8.13 ampere, and this is the peak value of current. So I hope you have understood this one. Now let's go for next part. Next pass, read the question carefully so that you can understand the question. Determine the RMS potential drop across the three element of the circuit. Shows that potential drop across across the LC's combination is 0 at resonance frequency. So I will come up this part later. First of all, you need to determine the RMS potential drop across three elements. So we have how many elements? So let us draw it. We have three elements, that is, first is inductor, this one is capacitor, and this is resistance, and this is our AC supply, right? If you see this one, resistance will be, for this one it will be XL, this will be XC, and this will be R, right? Now we need to find the current. So current see, current we have got as 8.13 in earlier. See, this we have got, this current we have got. So current basically we have I naught is equal to 8.13, and voltage we have as a VRMS, and this is equal to 230 volt, right? 230 volt we have, they have provided you. Got it? DRMS they have provided it. Now we want voltage at this section, so what to do? So voltage at L, voltage at C, voltage at R. So we will go one by one. So let us talk about voltage at inductor. So voltage at inductor, that is RMS voltage, will be equal to how much? So this will be equal to current I, V is equal to I into what is the resistance. So this one is the resistance, so this will be I into XL, right? Now what is the value of I? So we don't have a current, or we can use, see, we have either you can use this current, or we can use I is equal to V RMS. divided by resistance R, and this is equal to into omega L. We can use this one. Okay, why I am writing this one? See R, because they in this section they are telling that combination is zero at the resonating frequency, right? Resonating frequency, when they are using resonating frequency, the word resonating frequency, right? Resonating frequency, when they are using, so what to do? It means that XL is equal to XC. So overall resistance will be how much? Z, that is impedance. We have done this one. So that's why I'm using this one only. Why we are not writing it separately, right? So we need to write a VRMS. So VRMS is equal to how much? VRMS is 230. Resistance is 40 into omega is 50 into L, that is inductance is how much? Inductance L is 5. Just now check it. Inductance they have given you 5, right? So just put the values. So when you put the value, so we will get voltage as 1437.5 volt. Now next part for this one is voltage across the capacitor. So this is voltage across the inductor. So let us check voltage across the sorry capacitance, right? We can write here voltage across capacitor, right? Capacitor. So voltage across a capacitor, we can write it, right? VC RMS is equal to IRMS into XC. So IRMS is equal to, we can write IRMS is equal to VRMS by R divided by R. Again same condition, why I am writing R into XC means 1 by omega C. Just put the value. So we will have a 230 volt divided by resistance, that is equal to 40 into 1 by omega C means omega we have 50 into capacitance means 50 into 10 to the power minus. No, one thing I have done mistake. So let us check it now one again. No, it's okay. So I thought something else. So 1 by omega means omega, that is frequency. Resonating frequency is how much? Omega we have got 5 radian per second. So omega is 5 into C, that is capacitance. How much they have provided you? Capacitance they have provided you, C is 80 microfarad, right? So this will be how much? 80 minus 6. I think yeah, omega is 5. I am sure that omega will be 50. No, why 5? Omega we have, I think it is 50 radian per second, right? Just check it, correct it so that you can understand. Let's say again, I want to calculate it. So this will be how much? 45 400 400. So this will be how much? 10 to the 6, so 1000 divided by 20. So this will be 50. Sorry, by mistake I have written this 150. This will be 50 only, right? So we have to use this as a 50. So when you will get 50, so this will be VC into RMS, and this is equal to 1437.5 volt. Okay. So I hope you clear now. Now this one. This is saying that so that the potential drop across LC combination is zero. LC combination means potential drop means, let us suppose VL is this potential and VC is this potential. Now the value we have found is 14. What value we have found? 1437.5. So in both the case 1437.5 volts are there. So VC is equal to VL. So there is no drop. So if VC is equal to, see, if VC, let us write here. In this case, what happened? VC is equal to VL. So potential potential drop potential drop across VC to VL, VCL is equal to VC minus VL, and this will be equal to 0. So I hope you have understood this one. So thank you for watching our channel. So if you want to get one more, if you want to get more insight from this question, so just or more subscription, so thank you everyone.